Hello everyone, welcome you all again in my YouTube channel. Today we will start a new topic, that is gravitation. It's a very important chapter from physics. So let's start our topic. So at the first we should have the knowledge of the concept. What is the force of gravitation? What is the meaning of it? Just take one example. Suppose I have the marker and I am throwing it upwards, and after reaching one certain height we can see the marker is moving down and it's come back to my hand again. So why the incident is happening? If you throw any object upwards, why the object is coming down? That is only because of gravitation force. What is gravitation? So we can say gravitation is such a force by which any object can attract to another object. So when we are throwing any pen, pencil, anything, any substance, any object upwards, so that time who is taking the responsibility to attract them? Our earth. Our earth. So earth is giving the force of attraction by which the objects are moving down. This force is called gravitation. Okay? Acha. So next we are learning the universal law of gravitation. So what is the universal law of gravitation? Suppose we have two objects. This is capital M. Definitely this is for the higher or the bigger object, and the small m, smaller object. And we have kept them at the distance of d. Fine. So what is the concept of our gravitation? Just now we have learned keep the force of attraction acting between two objects, any two objects, that is to be called gravitation. So here, what is the force? Then we will write force equivalent to m1 into m2, or you can say capital M into small m. That means product of two masses. So I can say this is called the product of two masses, capital M into small m. Then this is inversely proportional to the square of the distance. D is the distance between capital M and small m. So inversely proportional, that is 1 by d square. Okay. Now these two things I am combining. So after making the combination, I am getting over here F equal to capital G into M, capital M into small m divided by d square. So you may ask me, what is capital G? G is called constant of proportionality. Here this is the symbol of proportion, this is also the symbol of proportion, but here I have given the equal symbol. So from the proportional symbol, how can I give the equal symbol? So definitely I require the constant. Here capital G is that constant. Okay? And we say this is universal constant. Why it is universal? Because the value of capital G is not being changed. On the earth, the value of capital G 6.7 into 10 to the power minus 11 Newton meter square per kg square. The same value you will get for the G if you will move to the moon or anywhere else, any places. Wherever you wish to go, you go. But the value of G always remains constant. And that is why we say this is universal constant. Okay? Achha, here what I have shown you, how to find out the unit of universal constant. So two types of question may come. If you get the question for 1 mark, write the unit of capital G. So simply you can write Newton meter square per kg square. That's all, problem solved. Done. But if in the question paper you see establish or determine the unit of capital G, in that case how can you solve it? that is why I have done the calculation. F equal to capital G into capital M into small m by d square. So what is G? Capital G equal to F d square by capital M into small m. So what is the SI unit of force? That is Newton. Then what is the SI unit of distance? Meter. Here I have the square. So this is meter square. Now whole divided by capital M into small m. That means kg. The SI unit of mass kg. So it will be kg square. Now I am getting the unit. Newton meter square per kg square. What is the value of it? This is 6.7 into 10 to the power minus 11 Newton meter square per kg square. Okay. Achha. So here we have done the concept of universal constant. Then what is this? Small g. Small g is to be called acceleration due to gravity. Now what is acceleration due to gravity? Now as Earth attracts everything, every object is getting the attraction due to our Earth's gravitation. So there must be a change of their velocity. I repeat, suppose I throw an object to upwards. Okay. So due to the gravitation, we know it will come down. So who is the responsible? We know Earth, our Earth. So Earth is giving the gravitational force, and that is why it is moving down. So if I ask, during the whole system, so the velocity is unchanged. Is the velocity same? No, the velocity is not same here, because definitely the velocity will be affected due to the force of gravitation. And we know the change of velocity per unit time, this is called acceleration. So the acceleration that will be produced due to gravitational force, that is to be called acceleration due to gravity, and that is represented by small g. Okay, acceleration due to gravity, that is small g. Now coming to the relation between them. What is the relation? See, here we have written F equal to m into g. So from where we have got this formula? Definitely from Newton's second law. Just remember one thing, in Newton's second law we have done like F equal to m into a. So a is the acceleration, right? So here instead of small a, I have written g, because this is also acceleration. So F equal to m into g I have written over here. And then this is the universal law of gravitation. F equal to g into capital M small m by d square. Now this is the value of F. This is the value of F. Now you can compare them. Okay. So by comparing, I am getting over here ki Gm equal to capital G into capital M small m divided by d square. Now from the both side you can cancel small m and small m. So what the thing you will get from here? Small g equal to capital G into capital M by d square. Gm by d square. This is the relation between small g and capital G. So if you get the question, actually this is a very important question, ki write the relation between acceleration due to gravity and the constant of universal constant. So what the thing you will write? If the question will come for the 1 mark, if it is a short question, so only this line is sufficient. This is the relation between acceleration due to gravity and universal constant. Small g equal to capital G G into capital M by D square. But if you get the same question for 2 marks, so in that case you have to show the calculation. F equal to mg, then universal law of the gravitation. After that you will do the comparison. From there you will cut the small m from left side and from the right side. After that you will be able to get g equal to small g equal to capital G into capital M divided by D square. Fine? Acha. Last, for today only just one topic I will discuss, that is centripetal force. What is centripetal force? Suppose I have a stone. Now I am using one thread. I have binded the stone with the thread, and now I'm moving. The stone is moving around myself. Okay, like the solar system. At the middle we have the sun, and the different planets are moving around the sun. Like the same way I have the stone, I'm doing like this way. So in that case, the substance which is moving around myself, that is that is feeling a force towards the center, and that force is to be called centripetal force. So what is the name of the force? Centripetal force. How and from where it is created? The centripetal force is created due to the movement of the substance. As the substance is moving around myself, due to the motion, one force is being felt by the object, that is towards the center, and that is why the name is centripetal force. And another force is also happening with the same time, that is called centrifugal force. So what is centrifugal force? Centrifugal force is measured when the same force will be produced outside, towards the outside, because the object is moving in a round. Fine? So one force is coming towards the center, that is centripetal. One force is going towards the outside. That outside force is called centrifugal force. Okay? So the same thing we see in the solar system also. Suppose our earth is moving around the sun. So at the same time the earth is having two kinds of forces, centripetal, centrifugal. Centrifugal force will be at the outside of the orbit, and centripetal is towards the center. Okay? Now for today up to this point sufficient, and this is the part 1 from the chapter Gravitation. In the second part I will explain the rest of the topic. Okay? Bye everyone.